Hi, a viewer called Roger asked would I be to have a look at this clamp meter. And what he said was the display isn't lighting up, however the little flashlight bit works and also the voltage check thing works. So if I put this next to a power source here, you can see the light lighting up. So that part works and the little flashlight works, but nothing on the display, even if you switch it on there. We're not getting anything. So I think the first thing we'll do is we'll take the batteries out, we'll take the back off and we'll see if we can figure out what's wrong with it. Looks like we've got about 3 screws to remove on the back. Let's pop these batteries out. We'll just check those batteries just in case, but I'm sure you'd have checked the batteries before we sent it. Just want the volts DC. Yep, 1.5. Yep, so the batteries are okay. Right, I'll just zoom down a little bit and we'll see how it comes apart. Now it looks like this white part might have to come off, because it's not going to come apart like that, because that's one solid piece. What have I got to try and get that off with? I'll try a couple of these plastic tools, but I'm not sure how that bit comes off. Right, I managed to get a screwdriver underneath it and kind of pop that bit off first. So let's see what we've got in here. So I think we're going to have to take the circuit board out. So I might get this one under the microscope just so we can get a bit better look at it. We'll have a look over this circuit board. Right, I'll just set the microscope up. Right, got the microscope set up. Let's have a look over this board then. So the power comes in just here. We've got a 0 ohm resistor. Maybe worth checking that in case that's gone open circuit. We've got a few 0 ohm resistors down the bottom there. That's where the clamp plugs into. Hold on. What's this here? We've got an inductor that's broken away there, but it still looks like it's actually making connection. So I wonder if this is being dropped at some point. Let's just check that we're actually getting resistance from that side to that side, or continuity. Well, I'll just go onto the meter here. Yeah, we're still getting continuity through that. Well, that could be one suspect thing there. So I think the next thing we need to do is actually take this board out. Just remove this clamp here. Right, well I can't remove the board fully because we have some cables at the front here. I'll just see if I can flip it over a bit. I'm not sure if there's anything underneath this liquid crystal display here. So I would have thought there's going to be some kind of microcontroller somewhere. Let's see if I can take this display off. I think there's only one screw holding it in. So that's the main chip with a website address on it. And we've got a 4 MHz crystal there as well. Well, the only thing that I've noticed up to now is that inductor here. I mean, it could be something to do with that because they're normally used on power supplies. I don't know whether that's some kind of boost converter or whether it's just being used as filtering or something, maybe. Looks like maybe a couple of op amps there. There's not actually a great deal on this. So I think what I'll do next is I'll put the batteries back in and then we'll see if we're getting voltages anywhere. So I've had to half reassemble this because of the switch. Because I couldn't switch it on otherwise because the fingers touch against the PCB here. So let's just switch it on. Let's just see if we get any voltage on this chip here. Right, so we've got just over 3 volts there. Let's try switching this off. And now we don't have any voltage, right? So the on-off switch appears to be working. Yeah. I was wondering if this has had impact damage with that inductor being sort of like that. I know we have a crystal under here which goes to the main chip. It could be that the crystal's broke. I don't know what's going on with that capacitor here. It just looks a bit weird. It's going to be a bit awkward to test this one because, like I said, because of the switch here. So we can't just take the board out and then, because we can't switch it on. So it's going to be a bit tricky, this one, I think. We've got another IC here. You know, I'll just try removing this clamp cable. Let's see if we get power on this chip. Yes, we've got 3 volts there as well. I just thought I'd check the soldering on this main chip here, just in case there's any bad solder joints or anything. I'm not sure about that one right at the end here. It might just be the angle that I've got it at. I know there's 2 pins joined together there, but they're all joined together in any case, so it doesn't make any difference, that one. If you look here, that whole row along the bottom here are joined together. Looks like the top row pins here are mainly for the display. I'm going to have a look on the internet just to see if I can find a data sheet for this chip. So it's an FS972D. Right, I'll see if I can find any information on this chip. Well, I've had a look on the internet and I managed to find a data sheet for this chip. I'll just bring it up so you can have a look. And if we look where the power comes in, it's actually the third pin down on the right hand side. So if we just go back to the microscope now, so it's actually that pin there should be the power for this chip. And that seems to go under the chip, but it also seems to come up here, goes to a wire there, and then goes to this capacitor here. So what I might do, I might get this in the X-ray machine so we can X-ray the board and hopefully see if we can work out where the power comes from. Right then, to the X-ray machine. Right, let's zoom in a bit. So this is the power rail here. You can see where it goes to that pin. I can't quite see where else it goes though. Looks like it's a component on the back of the board there. It's a bit hard to see with the other legs. I wasn't sure there's another trace goes under the board and over that way, but maybe not. We can see inside one of the chips here on the top. That's the little torch LED there. That's one of the other ICs on the other side of the board. You can actually see the die of the chip on the inside there. You can see the bond wires. Let's see if I can zoom in a little bit more. There you can see the bond wires going to the actual silicon chip there in the middle of the picture. It's quite cool, that. Well, I've spent a fair bit of time on this trying to work out what's going on. And on this capacitor here, we should have 3 volts that supplies the chip. So if I just switch it on, I'll just put it back together yet again. So that's switched on now. And if I just get my probes on the right way, just go here and let's go on ground. We've only got 0.1 of a volt going to the chip supply, and we should have at least 3 volts there, so that's why it's not working. So I've been trying to trace through the circuit to see what's going on, and this thing here, which is marked U5, seems to be a voltage regulator, because that's ground. This one seems to be the output, and this one seems to be the input. So if I just go onto the meter here, I've just got it switched on still. If I just go on ground, that's the output. And we've got 0.3 of a volt. And if I go on here, which should be the input, we've got about 0.6 of a volt. So I've been tracing this through, it sort of disappears here through this diode, goes to a wire, and then it goes all over the place. But I've eventually traced it out to this transistor here. So we've got, when we switch it on, we've got 3 volts here. I'll just show you that. So if I just go into ground, and I'll just go on to that pin there, you can see, let's just swap those leads around. Let's go on there. You can see we've got 3 volts. but we don't seem to have anything coming out of it. Now the weird thing is, we've got a resistor here. Now this side of the resistor is 2.5 volts, and this side 0. So I would have thought that resistor should have been pulling this down and then sending the 3 volts from here to here, which then ends up at the voltage regulator. So I'm kind of suspecting this transistor here at the moment, as it just doesn't seem quite right. So I have tested it with the meter and I'm getting readings on it. I'm not getting shorts or anything, but I'm wondering if it's sort of failed kind of open. So I'm going to have a hunt around, see if I can find a suitable replacement, and then we'll continue once I've found one. Right, let's have a go at removing this transistor. Let's put a bit of flux on it first. And I might use a little bit low melt solder on it. Just clean that up with a little bit of solder wick. Just going to add a little bit of solder to this pad first. Right, I think that'll do for that. Right, let's test this transistor just to see if it's open circuit or anything. Well, it's measuring okay that way. Measuring okay that way. And we shouldn't get anything that way. Mightn't be the transistor. Let's just see if we get any voltage when we switch this on now then. Right, I'll just switch it on. I'll just go on this cap here. 20 volts DC. So I can use the ground there. Nope, we've still got 0.3. So I guess it's not the transistor then. So I might pop the other one back in then. And then we'll have to investigate this a bit further. Right, I've just refitted the original transistor. So that's the power in, that's the power out, and this is the base here. So we'll go through this resistor, which is a 2K by the look of it. And then I think it's controlled possibly by this IC here. So let's just check this resistor here. I'm just going to ohms. And I've got meg ohms there, about 18 meg, and that should be 2K that. I think we might have found the problem. Right, I'll see if I can find a resistor then. Back in a moment. Right, back with a replacement resistor. Let's see if I can put that down there somewhere. Let's find my little dental pick just to get it off the tweezers. So we'll remove that one next. Right, let's see what that measures on the test meter. And that one measures 2K. And that one's open circuit. I'm measuring all kinds of weird values there. So I think we found the problem. Right, I'll get this microscope out of the way then and we'll see what it's doing now. Well, I've put it back together. We're getting a display on it now. However, I still think it's got more problems. If I go on to hertz, it says 0. If I go on to AC amps, that seems to go okay. If I go on to DC amps, it seems to go off the scale for some reason. And also, it doesn't look like the backlight's working. Nothing's ever straightforward. Right, let's get it back under the microscope again then. So this is where the backlight connects to. This one's ground, and this is where the voltage comes to light the backlight up. And I've just been tracing it through, and it seems to go along here through this 0 ohm resistor. So we'll just check that. That's okay. And if we just go along a little bit more, over the microscope slightly, it goes through this trace here and goes to this transistor here. So we'll just go from there to there. And that seems to be controlled from the IC via this pin here. And it goes through a 10K resistor. This is the supply into the transistor, this is the output, and this is the base where it controls it from. That goes to the actual IC, and we've got a 10K resistor here. Now if we just measure that, we've got mega ohms again. It's like, what's going on with this? How come we've got resistors that just seem to be randomly failing? So I'll go and find a 10K resistor and we'll see if that sorts out the backlight problem. Just put a bit fresh solder on this resistor first. That's the old one removed. I'm going to put a bit of flux on that just to make it a little bit more neater. Right, let's see what that measures then. That's better. 10K. What on earth's going on with this? Right, let's see if the backlight works now then. Right, so I'll switch it on. Yes, I've just seen it light up there. You can actually see it glowing at the bottom there now. So let's have, I'm thinking we'll have to check some other resistors on this. I'll probably have to check them all, I think. Unless it's supposed to do that, but I don't think it's supposed to do that. I'm sure there must be another resistor or something gone, but this is very strange. I've never had resistors just failing like that randomly. It's almost like somebody's put too high a voltage in it or something. Right, I'll have to do some more investigation on it then. So I've just unplugged the clamp ribbon cable here. And I thought I'd try measuring the resistors here. Let's get that out of the way again. So we've got 1.5K. Let's refocus this microscope a little bit. That's better. So we've got 1.5K there, and then 5.1K, 5.1K. But if we look, we've got mega ohms again on that one. If we go on this one, 5.1K, and go on this one, 5.6K. So that one's a little bit off, but that one there, mega ohms. So it looks like that resistor's gone as well. I wonder what's caused all these. I wonder if this has had some kind of power surge in the clamp and it's fried some resistors. And it's just a bit bizarre, this one. I don't think I've ever came across anything like this before. Right, let's just add a little bit of flux to that. Oh, I'm making a bit of a mess with this. Right, let's just measure that now. 5.1. Right, let's see what it does now then. Right, I've just switched it on and gone on to DC amps. Oh, that's better. So the display still isn't the brightest, it just depends what angle you hold it at. You can see it a bit better there. I don't know why that's climbing up. We still might have more problems on it. I think I best keep looking. So here's another one. I was getting a weird reading on this one, but I think there was another one across it. But when I measure that one, we get 470K, which is right. And this should be 10K. But I'm getting 30K from it. Right, I've just finished changing that one. Let's just check if we get 10K across it now. On Bazoo. And this is the one I've just removed. Getting all kinds of values on this. Very bizarre. If you have any ideas, leave it in the comments below. So just measure this 10K one here as well. Just measure that one there, and I'm getting 0.8 meg. I'm just wondering if you was measuring some high current and it's kind of fried something, or I'm just a bit of a loss with this one. It's all very strange. Yeah, definitely 0.8 meg there. And I haven't got the batteries in, so there's no power in this. So I just thought I'd slide that resistor to one side. And it's definitely gone. So my meter's okay there, you can see when I touch the probes together. Let's measure that 10K one that I've just changed. 10K. Well, that one, we're getting megs. Right, I'll go and find another resistor then. I just don't know what to make of this. I've never seen anything like this before, ever. There's the resistor I've just changed. 10K. And I thought I'll measure this 10K here. And it was actually just going all over the place a minute ago. It's 11.55, which I suppose it's near 10K. But I was just measuring it a minute ago. Well, there we go, we're at 12K now. But a minute ago it was showing 125K. But it's showing 12K now. Go back to that one I just changed. 10K. That one again. 10K. Right, I'm just going to keep on plugging away at this then, I think. So I've changed that one. And as you can see, measures 10K now. Well, there's another one. That's supposed to be 470K, like that one. Open circuit. So I need to change that one as well. Well, it appears to be working. We've got amps AC, hertz, and the DC amps does seem to be stuck at round about 3. Now I'm not sure if there's a calibration on this or not. If we hit the 0, I don't exactly know what 0 does. But when you unzero it, it goes back to 4 amps. Now there's a couple of trim pots inside, which may be for adjusting it, but I don't want to start messing around with it, just in case I make it any worse. But like I said, there's been a fair bit of damage in this. I mean, I must have replaced about 6 resistors in it. So I don't know what the cause of the problem is. The light's working okay. The mains detection, I don't know if I can show you that. Let's grab the dim bulb tester maybe. I don't know if that's switched on. Oh yeah, it is. there you go. So that's working. So I'll just give it a quick test upstairs on the electric meter and then we'll wrap up, I think. Well, I've just came into the cellar to try and measure amps on the mains electric here coming in. And it's saying about 4.5 amps that we're using at the moment. And most people's in bed because it's about 1:30 in the morning at the minute and the electric meter's just ticking over slowly there, as you can see. So I think that's probably about right. So I thought I'd try the DC amps. So I've got my bench power supply set up and limited to 5 amps at the moment. So I'll just switch it on. And we can see my meter's showing 5 amps there, or -5 because I've got it wired the other way around. And this has jumped up to nearly 9 amps, so if I just switch it off, it'll drop down to 4. So it is actually measuring amps, it's just got an offset of 4.0. So whether or not there's an adjustment inside that you can actually zero it in. But to get there, you've got to strip it all down and then you can't power it up. So yeah, I'm not messing about with that. So it is working, but not quite 100%. But it's definitely better than what it was. Right, so there we have it. The Perel AC/DC clamp meter. That was a bit of a chore. Right then, if you enjoyed this video, please give it the thumbs up. If you want to see more like it, please subscribe. Any comments or questions, please leave it in the comment section below. And as always, have a great day. Thanks for watching.